Hello everyone. In my last session, I introduced you sets, basic definition, some symbols, and now we go to next part, that is types of sets. Now, some of them may be quite trivial, which may be known also to you, but this session is only for formal introduction of all the terms what we use in topic sets. So, first is null set or empty set. And as name suggests, that in this collection, we do not expect any element. So, a set having no elements is called a null set. I have just shown one small round having no element in it. So, we just show it by two curly brackets, or we have a new symbol called phi. If you write phi, mind you, please do not use curly brackets outside. I mean, do not place that phi, the symbol, within curly bracket. If you are using phi for null set, we do not write curly bracket from outside. I hope everyone is clear. Either you just show two curly brackets, do not write any element inside, or you use notation phi. That is the notation for empty set. Next is singleton set. Again, as name suggests, we expect only one element in this set. So a set having single element or one element is called a singleton set. And how do we show it? Suppose A is some element of a set. Then we will be writing within curly brackets element A. No comma, no extra element, nothing. Now if I say, for example, x between 1 and 3, that means, and if I say x, say natural number, then that set will contain only number 2. So it could be a singleton set. So here I have taken one example where I write x such that x between 2 and 4 and x is integer. I could have said, since both the numbers are positive, I could have said natural number also. So this set will have only number 3 in it. So it is a singleton set. I go to next. Finite and infinite sets. As name suggests again, finite we are expecting finite number of elements. So a set whose elements are finite in number, or they can be listed separated by comma, that would be called a finite set. And a set which is not finite means you cannot list all the elements separated by comma. Such a set is called an infinite set. Now you can start recalling till now, I mean from whatever we have learned, that what can be examples of finite set, infinite set. And I'm sure you all must be ready with certain examples. So I take one example, say 1, 2, 3, 4 going up to 100. I cannot list all the elements, so I have used 3 dots. Now it is a finite set. I mean, though I have not listed all the elements, but those 3 dots are telling me that if I wish, I can write 5, 6, 7, etc. also. And I can keep writing till I arrive at 100. So number of elements is finite here. I can list all the elements separated by comma. So this is an example for finite sets. So I have actually again showed them separated by 3 dots. Next example I am taking as x greater or equal to 3, less or equal to 10. You remember this notation, what for we had used? We had used for closed interval. Set containing all such x such that x is greater or equal to 3 but less than 10. Recall, this was nothing but a closed interval. So this is an infinite set. Why do I say that it is an infinite set? Some of you, those who are still raw in the subject, may think that after 3, 4, 5, such numbers will appear. But 3.1, 3.2, between 3.1 and 3.2 also 3.11, 3.12, etc. So can we actually write all the numbers? No, we cannot. So we take help of nothing but that property method, and we realize that it is going to be nothing but infinite set. And I show it on number line as I mark 3, I mark 10, and then I show the square brackets to show that it is nothing but a closed interval. I take next type of sets. It is subset of a set. As again, name suggests, the moment I am writing their sub, you all have understood that only part of set I am requiring. So I will say a set A is subset of set B if every element of set A belongs to set B. Now, can we use this statement again and again? I mean, this is a quite long statement. So, we use certain notation, and notation is A, we write B, and between A and B, C kind of letter we are writing, and I am writing there below one small horizontal line also, and that stands for that subset kind of thing. Realize this. Similar notation in case of numbers we have seen, like less or equal to. I mean, it is just only analogy I'm trying to give you. That when we say x less or equal to 10, so x can be 10, x can be less than 10 also. Similarly, I'm saying here that elements of set A belong to set B, but I have not yet claimed anything. What happens to elements of set B? I mean, does set B have something extra, or it has exactly same as what set A has? So, because of that ambiguity, we have kept that small horizontal line. Let us take some example. If I have set of real numbers, capital R, I have set of rational numbers. Now we know all the rational numbers are real numbers. So I will say Q is a subset of R. I hope everybody understood the notation also and example also. Now let us refine this particular type of set, because just now I said that nothing we have mentioned about set B. We are just talking about set A. Then we say subset. Next type could be proper subset. That I say that every element of set A is in set B. So I will say X belongs to A implies X belongs to B. And I put some additional condition on set B, that there is some element Y in B which is not in A. Means set B is a larger set. It has something extra in it which is not in A. Then we say set A is a proper subset of set B. Now, similar notation is just that C kind of symbol I have written there. No like horizontal line. Now, let us take example similar to the previous one only. I show set R as set of real numbers. All the rational numbers are contained inside. So, set Q is completely inside R. And there is something extra which is outside Q, which I am showing as I. Please do not mind this I am writing for irrational numbers, not integers, right? So there are irrational numbers which are not in Q, but they are in R. They are in R, I mean capital R, the set of real numbers. Now, when to use subset, when to use proper subset, as subject proceeds, you will get that understanding. We go to next, and that is nothing but equal sets. Now, if every element of set A is in set B, and if every element of set B is also in set A, then we say two sets are equal. So, A is subset of B, B is subset of A, that leads to nothing but A equal to B. Now, there are certain types which are to be remembered. First, that empty set is a subset of every set. Set itself is a subset of it. If A is subset of B and B is subset of C, then A is subset of C, which was quite trivial. I mean, if you stretch your mind, you can write examples, you can verify it. And when I say A is subset of B, then we have not mentioned anything about B. B may be subset of A, or B may have something extra, and hence it may not be subset of A. Now, these are certain points which are to be remembered regarding subsets. Now, some two more types we will define. One is universal set. Universal set is the biggest set what you can think in your example. We say a set that contains all the sets under consideration. That is called the universal set. For example, if I wish, I can write that universal set U as set of real numbers if I am considering only rational numbers. Means if my set of consideration is Q, then set of real numbers can work as universal set. Mind you please, universal set is not unique. If you are just taking natural numbers, for example, in your consideration, then set of integers even may be universal set. And if you wish, you can write set of real numbers also as universal set. So universal set does not remain unique for a given case. Now next type could be power set. Now set containing all possible subsets of set, given set, I mean set A suppose, it is called power set. And the notation would be P, and inside bracket, round brackets, we write capital A. So that would represent power set. Mind you please, I repeat, set of all subsets of set A, means including empty set and the set itself. All possible subsets you have to write, put them under curly brackets, and that will be nothing but your power set. So power set notation would be PA equal to, and then we will write within curly brackets certain subsets. Now if I take set A as 1, 2, then write down first all possible subsets. Phi, empty set, that is subset. 1, 2, that is a subset. Singleton set 1, singleton set 2. Separate all these 4 elements. Now I'm calling them as elements. Why? Because they are going to be put under outside 2 curly brackets. So power set here will have 4 elements in it. Understand, initially power set, universal set, you find, I will not say difficult, but you will find them little cumbersome to use every time. I mean, to be so particular, but if you keep using, these terms would be in your habit. And here I end my session. When we meet next time, we will talk more about sets. Till then, stay tuned. Thank you.